All right. Well, today I had an old video. It didn't seem to work, so I'm going to have to talk you through this packet. I'm going to try to move kind of quickly and hit the highlights, and then if this has almost everything in this one, so I'll cover everything that's covered here, and then I will get the rest in a video for Monday. So we have statistics. And the main thing we need to understand about statistics is that we're trying to figure out patterns that are occurring in our world. So you think about maybe a presidential election where somebody would say, what percent of people are going to vote for this candidate or that candidate? And they would want to find statistics that show what's going on. Or with COVID, like what percent of people wearing masks or not wearing masks are affected by it, how deeply, if they're how bad are symptoms if they have got the vaccine or not got the vaccine, things like that, okay, would be statistical analysis. So let's start from the top. The first thing is the population. So when you're doing statistics or statistical analysis, you need the group that you're going to deal with. And the population is the total number of individuals being used. That doesn't mean that it's like just people. It could be number of trees if you were trying to look at disease on trees, or it could be number of squirrels if you were trying to see, I don't know, the squirrel population, whatever. But a population would be the individual pieces of a group you're looking at. Cars, if you're trying to measure safety of different types of cars. And then a parameter is a value that represents some characteristic of the population. So let's say it's cars. Would it be color? Would it be safety? Would it be horsepower? Would it be comfort? Whatever would be a parameter. So you've got two things going on when you deal with these parameters. One thing is the population mean, which that looks sort of like an M. It's called mu. A population mean and population proportion, P. Okay, so we're going to deal with both the population mean and the population proportion. We'll come back to those in a little bit. And then you've got a census. So a census is a study that includes everyone. So when they do the census in the United States, everyone always talks about how that's hard to do because it's hard to get everyone. What about someone, if you go to homes, that's not enough. What about someone who's homeless? If you use phones, that's not enough because now no one has a landline. But censuses are usually too hard. A census doesn't just have to be people. Like it could be all the trees in the forest or whatever. So you can't figure out what needs to be looked at because you can't get everything in a group. So we often choose a sample from the set of people. Okay, so a sample is a set of the population. So we're here, a set of the population. Okay, that we actually examine in order to gather information of the population. So we choose a group and say we're going to study them instead of everybody. And then a statistic is numerical. It's a value that represents a characteristic of the population. So they're not represented by Greek letters, though. So there's the sample mean, which we have in front of us. Okay, I'm trying to, give me 1 second. I'm trying to get this to where I can scroll. It doesn't want to. Exit drawing. I bet that'll let me do it. There we go. A sample mean and a sample proportion. So we'll talk about those more as we go forward. So the sample mean and the sample proportion. Now, look up here. We talked about population mean versus sample mean. I will touch on this. Population mean, the mean is the average, if you want a word for it. Mean, average. So the population average. So if you took the average of every single person or car or whatever that you were measuring of something. Whereas the sample mean is this is the only group I'm going to use, like these 100 cars or these 55 trees or these 3,000 people, whatever. That would be the sample mean. Okay? And we'll talk more about the population proportion and the sample proportion in a minute. Okay? All right. So parameters are usually not known because they can be difficult to calculate. Okay? So we use samples to estimate parameters. We use samples to estimate parameters. Statistics will vary, but parameters do not. So remember what parameters are. Okay, the parameter is the value that represents the characteristic of the population. Okay, so let's do a few that may help you through those notes. So a survey will be given to 100 students randomly selected from freshman class at Lincoln High School. So what is the population? Well, the whole population is all the freshmen, right? The sample is the 100 randomly selected freshmen. Does that make sense? Okay, in number 2. So 50 bottles of water were randomly selected from a large collection of bottles in a company's warehouse. And the volume of water in each bottle was carefully measured. The stated volume on labels of the bottles was 12 ounces. The mean volume was, as measured, was 12.1 ounces. Okay, so the parameter is the amount of water in each bottle. But the actual statistic, what we found, okay, was that 12.1 ounces was in the sample on average. Okay, so there was this sample amount and there was 12.1 ounces in the sample. Okay, and then the next part, identify whether the underlying value is a statistic or a parameter. Use the proper notation for each. So a sample of 200 middle school students shows that 58% of 8th graders are nervous about starting high school. Okay, that's a statistic because it's numerical. Parameters and statistics are numerical, but it's a numerical example that's only from the sample. It's only from the sample. Okay? And the sample proportion is like 58%. So I'll talk about that now, the sample proportion. So when you think about 58%, that's kind of saying, okay, 58 out of every 100 students. 58%, 58 out of 100. So that's a proportion. Letter B, the average salary of all first-year teachers in the state of North Carolina is $29,100. When the News and Observer interviewed 50 first-year teachers in Wake County, they found their salary was $30,779. So the second part of that, the Wake County 50 teachers, is a statistic because it's not everybody. And this is the sample mean. This is the average. Their average salary is $30,779. So the sample mean is the sample average. Now, technically, the first sentence there could be called a parameter because it's all first-year teachers. It's the whole group. And therefore, that would not be a sample mean. That would be the parameter mean or the population mean. Okay? Then letter C. In spring of 1994 issue, Self Magazine reported that 84% of its readers who responded to a mail-in poll indicated they used the alternative medicine such as acupuncture. Again, it's a statistics because it's mail-in poll. It's not every single one of its readers. And that is a sample proportion, 84% or 84 out of every 100 people. Now, so that you don't have to watch this video forever, I would say to you to go ahead and do this next group of questions. And you may not have them all on there from this sheet I've got here, but I'll leave them up here and I'd pause it and kind of check your answers. So I'll do this. I'll kind of let it sit here. You should pause it, and then I'll scroll it up. You pause it again, and work through it and check your answers. And then I'm going to go on to the next part. Again, by the way, you may not have some of these questions, but you could use them. You could use them to study by. I'm sorry I had to punt and do something a little differently, but I wanted to make sure you guys had this if you needed it. Okay, so hopefully you paused. If not, go back, pause, and check those questions. And be ready to ask me questions. That's fine. So next is on the next page, okay, and right now you should be on the back of the first page. okay? You've got experiments versus observational studies. Now, this is a big one because this is going to show up for you a decent amount. This probably you'll have something on this on the EOC. This is something you're supposed to understand and know. In an experiment, researchers apply treatments to experimental units, people, animals, plots of land, and then proceed to observe the effects. So an experiment, they do something. That's pretty much it. In an experiment, you actually do something to the group and see what happens. Now, an experiment, by the way, always requires a group that is not affected by whatever you're doing, but that doesn't really affect these questions, I think. In an observational study, researchers observe subjects and measure variables of interest without assigning treatments to subjects. So observational study means I just look and see what's going on, okay? So I might go, oh, okay, 85% of women enjoy blank. 95% of cats tend to blank, okay? I'm just observing the data. I'm not doing anything. I'm just looking from the outside, okay? So let's look at just a few of those. So number one, in an attempt to study the health effects of air pollution, a group of researchers selected 6 cities in very different environments, some from an urban setting, some from heavy industrial setting, and some from rural setting. Altogether, they selected 8,000 subjects from the 6 cities and followed their health for the next 20 years. At the time of their health prognoses, their health prognoses were compared with measurements of air pollutions in the 6 cities. This is an observational study. And there's no treatment. You won't have a treatment in an observational study because treatment means something's happening. They're not doing anything. They're just looking at what's happening. Number 2, among the groups of women aged 65 and older who were tracked for several years, those who had a vitamin B12 deficiency were twice as likely to suffer severe depression as those who did not. Again, observational study. You're just looking at the data. You're not doing any treatment, okay? All right, number 3, 40 volunteers suffering from insomnia were divided into 2 groups. The first group was assigned to a special no dessert diet, while the other continued dessert as usual. Half of the people in each of these groups were randomly assigned to an exercise program, while the others did not exercise. Those who ate no desserts and engaged in exercise showed the most improvement. So it was an experiment here, and there was a treatment involved. They were split up into groups, okay? And that's why I know there's a treatment. So some of the groups ate no dessert, some ate dessert, some exercised, some didn't, some did both, some did neither, okay? All right, so I hope you're getting the hang of it. I'm going to let you go ahead and do these, and I'll, again, put the answers right here so you can look at them. And then if you want to, you can pause, do these, and then look at the answers or whatever. And again, if you have questions on Monday or whenever, then you can ask. Well, not during the test, but otherwise. All right, so the types of sampling techniques, okay? So the goal of sampling is to obtain a sample that represents the population, okay? So you want to figure out what would the population do. Honestly, it's been sort of interesting over the last few years. Some of our polls and data from elections have not been too good, and that bothers people. If what's said to if what it is said is going to happen doesn't happen, or at least close, there's some flexibility, which we'll talk about. But if that doesn't happen, then that kind of bothers people. If you say, oh, there's 87% of people are going to do this, and then only 12% do it, you're like, wait a second, there's something wrong here. You want that data, that sampling to be effective. So the best way to keep your samples free from bias is to use random processes. So bias is what often affects sampling data. It can be biased by the actual person. They can use the data to their goals, or it can be biased because they didn't use a random process. You want to pull out as much of your own control over that as possible. So there's different types of samples. So here they are. So convenience sampling is contacting people who are easy to reach. So I could distribute a survey to my class. That would be easy. but my class may feel differently than the rest of the students. Say the survey was about should seniors get longer lunches? Well, if it's a senior class, yeah, they're going to say yeah. If it's a freshman class, they're going to be like, no. Does that make sense? So it's easy, but a lot of times there's a fault there because it's not going to give you really good data. There's voluntary, so people volunteer. The problem with this one is if I say, hey, you guys, if you want to be a part of, whatever, of my sample survey, then just come by. Well, the problem is people who do this normally have strong feelings, either positive or negative. You're not going to get a good data set. If you go to a restaurant and people say, take the survey, either people are amazed by the food or they hate it. And that's the only people you're going to get to fill things out. So voluntary is not going to give you a good feel for maybe the entire population. And then you got a simple random sample. So you give each member of the population an equal chance of being chosen. That's names in a hat, or ID numbers as I have here, whatever. Something very simple. So simple random sample, you're just picking. The problem with simple random sample is sometimes you can accidentally get too many of one population, of one group. So say you're trying to find, ethnically, like, okay, so we want a good feedback from African-American students, from Latino students, from white students, from Asian students. Like we want a good feel from all of those different groups. Simple random, you could end up with a lot of people from one group, which is why stratified random is a little bit better. You could take the groups that you have, whatever 4 or 5 groups you have, or 2 groups or whatever, and you say, we're going to pick the same number of people from each of those groups. So your subgroups, you pull them out. And those are called strata, because stratified. So these different strata. Okay, so you could do that in schools, grade levels. You could say, okay, I'm going to choose 10 freshmen, 10 sophomores, 10 juniors, 10 seniors, and then I'm going to use my measure. Well, then there's cluster. Now, stratified and cluster is going to get you most confused. Stratified, you split into groups and you pick the same number of people from each group. Cluster, you split into subgroups, and normally it's not by strata. You just split up into subgroups, and then you take all of a few groups. So here, listen again. Stratified, you have a bunch of groups, and you pick a few from each group. Cluster, you split up into groups, and you just pick a few of the groups. So all of group A, all of group B, but not group C and D. Whereas in stratified, you'd pick a few from group A, a few from group B, a few from group C, a few from group D. Okay? And then systematic random sample, okay, is where you might do, like here it says, you have a list of students, you do every 5th student. So there's some sort of every 4th person, every 2nd person, whatever, okay, every 25th person. All right? Does that make sense? I hope so. I guess you can't answer me. So what I would say now, let's go through these real quick, and then I'm going to let you practice. Okay. So in a large school system with 20 elementary schools, the school board is considering the adoption of a new policy that would require elementary students to pass a test in order to be promoted to the next grade. The PTA wants to find out whether parents agree with this plan. Listed below are some of the ideas proposed for gathering data. For each, indicate what kind of sampling strategy is involved. So put a big ad in the newspaper asking people to log their opinions. Well, that's voluntary, right? Because you're saying, volunteer to tell me what you think. Letter B, randomly select one of the elementary schools and contact every parent by phone. That could, that would be convenience. I agree with my answer. It's easy just to pick that one school and then go with it, okay? All right, the next one, each student is assigned a unique student ID number. Obtain a list of student ID numbers, randomly select 100 from the list. It would be simple random. You're just taking everybody and picking some people random. Letter D, randomly select 20 parents from each elementary school, send them a survey, follow up. So now you've got a bunch of groups. Each strata is each school, and you're picking 20 people from each strata. So it's a stratified random sample. And then the last one, you go through and record every 40th parent. That's systematic, okay? So now I know I'm going through this quickly, but you can ask me questions on Monday or Tuesday or Wednesday. But I'm going to leave up the answers for this section, for the section that's upcoming. And by the way, right now you should be on the second page, like the front of the second page of the packet. And I'm just going to leave these answers up so that you can check your answers, okay? And then you can pause it if you want. I'm trying to get them all on. That's pretty close, but there you go. So pause it if you want to look at them, because I'm going to keep going in just a second. All right. So that actually ends that part of the section. So what we will do is I will do a video, and I'll put up the second one so that you can get, all that's left now is the last 2 pages. So that knocked out a lot of it, and we'll do the last 2 pages, and then you will have it done. So I'll upload this, and it'll be there for you for the next few days. All right. Thanks. Bye-bye.